Okay, today we'll be discussing two different questions of complex number. The first question is -1 plus I to the power 8. So we'll be using same process that we used before. So first of all, we will compare this complex number with the standard form, and we'll get the value of x as -1 and y as 1. Again, rewriting in the form of polar coordinate, we will get the two different equations, that is x is equals to r cos theta and y is equals to r sin theta. So after computing these two equations, we find the value of r, and the value of r is root over 2 here. Again, by dividing these two equations, equation 4 and equation 5, we will eventually get the value of theta as 3 pi by 4. So the complex number z, that is equals to r cos theta plus I sin theta, can be rewritten as root over 2, that is the value of r, and the value of theta is 3 pi by 4. Similarly, in the imaginary part also, we have I sin 3 pi divided by 4. So finally, we have the equation root over 2 e to the power I 3 pi divided by 4. And now we have multiplied this equation 6 with e to the power I 2 m pi. As we know, the value of e to the power I 2 m pi, that is equals to 1. So we have multiplied this term with our given complex number. So after some calculation, uh, as we know, the power that is present here is 8. So uh, we have written the power of z as to the power of 8, and for all the other terms we have extended the power as 8. So after we compute uh, this equation, then we will get the result as z to the power 8, that is equals to 2 to the power 4 e to the power I 6 pi. And after that, we can write in the extended form as 2 to the power 4 times cos 6 pi plus I sin 6 pi. And eventually, we can write cos 6 pi as 1 and the value of sin 6 pi as 0. So the only one result that we can get from this given complex number is 16. Now we plot this given value in a Argand diagram where we can locate our result in this way. So the second question is -1 plus I to the power 1 by 5. So as we can see here, in the previous question, we had the power of 8, but here we have the power in the form of 1 divided by 5. So we'll do the same process. First of all, we'll compare this with the standard form of complex number, and we write in the form of polar coordinate form. Here also, as similar to the first question, we get the value of r as root over 2 and the theta as 3 pi divided by 4. But one different thing that we will do here is we use de Moivre's theorem, because the power that is given in the complex number is 1 over 5. So we must find out 5 different values of this given complex number. So here we use the de Moivre's theorem, and we reduce the power as 1 by 5, because that is given in the equation. So after putting the value of the complex number 1 over 5, then we will get the result as 2 to the power 1 by 10 times e to the power I 3 pi divided by 20 plus 2 m pi divided by 5. So here we will be putting the value of m as different numbers. So if the value of m is 0, then we can find the value of a as like this. So a is equals to 2 to the power 1 by 10 cos 3 pi by 20 plus I sin 3 pi divided by 20. If we put the value of m as 1, then we can find the value of b as 2 to the power 1 by 10, that is negative cos 9 pi divided by 20 plus I sin 9 pi divided by 20. Similarly, in the next step, we will put the value of m as -2, and we will put the value of m as -1. And the final result that we can obtain of this complex number are listed here. So these are the values. These are the 5 different values of the given complex number. And after that, we'll plot these values in an Argand diagram where we can see here the value of A both the real part and imaginary part are positive, so A is placed in the first quadrant. Similarly, for value B, real part is negative and the imaginary part is positive. So we have kept the value of B in the second quadrant. Similarly, C also lies in the second quadrant, and the value of D is the real part is negative and the imaginary part is also negative. So we must place the value of D in the third quadrant, and finally the value of E is positive in the real part and negative in the imaginary part. So it must be positioned at the fourth quadrant. So this is the Argand diagram of our question. Thank you.